इज दैट क्लियर? मतलब अभी तक समझ में आ रहा है सब? Okay, mostly these questions are not asked in your physics exam. Mostly they are not asked. Okay, uh, so you may expect them at interview level, and only if some mathematics person is sitting in your interview board. Otherwise, no. Okay, so only if a mathematics person is sitting in the interview board, only in that case he may ask such questions. But overall, they will not ask these questions. Overall, in examination wise, if I say Abel's formula will be the last thing that they may ask, and probably they may ask that if Wronskian is zero or non-zero, what you can say about the nature of the solutions, like whether they will be linear dependent or independent. Is that clear? Now, as we were discussing, second order homogeneous linear differential equation, in general, always you can see that if I'm discussing any in general, even as an nth order linear differential equation, even if I'm discussing an nth order homogeneous linear differential equation, this will be it. So any nth order homogeneous, I'm saying, homogeneous linear differential equation will always have a zero, a solution which is trivial, that is y equal to 0. So other than all solutions, one solution will always be there, that is y equal to 0. You can see that y equal to 0 satisfies this differential equation, isn't it? So for any homogeneous linear differential equation, rather we'll see that the set of the solution for the homogeneous linear differential equation would rather form a vector space over R. That we'll see later on. But right now, just understand my point, what I want to say, that any nth order linear differential equation, any nth order linear differential equation, any nth order homogeneous linear differential equation will always have one solution which is very true, that is trivially zero. Trivially zero, that is trivial zero, will always be a solution. Is that clear? Is that not clear? Whatever I'm stating, is that clear or is that not clear? Kindly let me know. Okay, so what I want to suggest is that let us say if I'm writing any differential equation, let's say d2y upon dx2 plus dy by dx plus y equal to 0. This is a homogeneous linear differential equation. Can you not write that y equal to 0 is a solution? Clearly it is this. 0, 0, 0. 0, the derivative of 0 is again 0, the second derivative is always 0. So always remember that trivial 0 is always a solution to a homogeneous linear differential equation. So these solutions, because this is very, always it will exist, so these solutions are called as trivial. Okay, so trivially 0, that is a trivial solution to it, will always be a solution. Like this is a trivial solution, this will always be there. Is that clear or not? Although for physical context, we may disregard it, but if you are in mathematics and if somebody asks you that will zero be a solution, you will always say yes, the solution will be there. Yes, it will be there. Is that clear or is that not clear?
Yes, sir.
Okay. So now coming to the last point of this entire thing, and which is I fear teaching physics students, but let me try it. So the Wronskian, I made it 0 in two possible fashions. One was to write the upper row as 0. So if at some point your upper row is 0, that is, if at some point you have common roots, then your Wronskian is 0. And if at some point your lower row, that is this row, if I'm saying it is 0, then your Wronskian would be 0. Okay. So if I say that my upper row is 0, it implies there would be some point x0 where I have some common zeros to the solution. And if I have a common zero, if I have common zero to the common zeros to my solutions y1 and y2, then y1 and y2 cannot be linearly independent. They have to be linearly dependent, because at some point I know that my Wronskian is 0. And if at some point I know that my Wronskian is 0, implies my Wronskian is 0 for entire interval of existence. The similar thing I can say for the lower determinant, a lower row as well. So if at some point I know that my lower row is 0, which implies that at some point I know my y1 dash is 0, y2 dash is 0. That is if I know that my functions y1 and y2 have common point of extrema, because this x naught happens to be an interior point to I, and if it satisfies this, so the necessary condition for existence of extrema, if the function is differentiable, is that the derivative at that point should be zero. So if the y1 and y2 have common point of extremum, then my Wronskian would be zero, implying y1 and y2 are linearly dependent, implying that if y1 and y2 are linearly independent, it cannot have common point of extremum. Now, let us come to one of the most difficult points, which mostly students don't get. But let me try. And if you get it, fine. If you don't get it, remember this result. Okay. So if I take this as zero, this entire column as zero, then it may so happen that your Wronskian is again zero, isn't it? Now, what does it mean? So I've taught you in other classes in complex analysis and other way also. If I say that my function is zero at a point, I mean that x here, yeah, at x naught, if my function is zero, I say that my x naught is a zero. And if my f dash x naught is non-zero, I say that my x naught is a simple zero. But for example, x minus 3. If my function is x minus 3, I know that at 3, my function is becoming 0, implying that 3 is a simple 0. How to verify it? Differentiate. So derivative is 1, which is non-zero. Clearly, I can write my function is at 3 has a simple 0. Is that clear? But what about fx equal to x minus 3 ka square? So here you will find that 3 is a root of multiplicity 2. Why? Because this is the root for function as well, and this is the root for the derivative as well. But f double dash 3 will be non-zero. So in general, if I want to write that if my x naught is a repeated root of multiplicity m, what does it mean? It means your fx naught must be 0. It means your f dash x naught must be 0. It means your f double dash x naught must be 0. Dash 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 your fm minus 1 x naught should be 0. But your fm x naught cannot be 0. So if this satisfies, if x naught satisfies this condition, I would like here this dash, double dash, m minus 1 and all those things represents the order of the derivative. If this is the case, then I'll write my x naught is a repeated 0 of multiplicity m. Okay, is that clear? Now, why I want to write all these things is, if I'm writing that my at some point x naught, my y1 is becoming 0, my y1 dash x naught is becoming 0, it implies that x naught is a repeated 0. Of y1 as a function of x. The first thing that comes to mind is that your x naught is a repeated 0 of y1x, isn't it? And if it is a repeated 0, then y1 and y2 are linearly dependent. So one thing that comes in mind, that if y1 and y2 are linearly independent, it implies y1 and y2 cannot have repeated roots. Because if they have repeated roots, then the solutions will be linearly dependent. So if y1 and y2 are linearly independent, y1 and y2 cannot have repeated root. Is that clear? And if at all there is a repeated root, then it happens, it will, if there is a repeated root, then it is very certain that y1 and y2 will be linearly dependent. But coming back to now the most important point, that is, what I have done is I'm not considering, I am not keeping any bounds on y2. Like y2 can be any damn function. Y2 can be any damn function. If x naught is the repeated 0, this entire column would become 0. And if this entire column is 0, I would say that my Wronskian is 0. And if my Wronskian is 0, implies y1 and y2 are linearly dependent. But I have not kept any restriction on y2. Y2 can be anything. Y2 can be anything. So see, so y2 can be sin x, for example. Y2 can be exponential. Y2 can be, let's say, x, anything. And I'm saying that if x naught is a repeated 0, then y1 and y2, which can be any function, any arbitrary function. Obviously, this arbitrary function has to satisfy the differential equation. But what I want to say, that for any choice of y2, my y1 is linearly dependent. Is that clear? This is what it means. If I'm saying this, my entire column is 0. If I'm saying this entire column is 0, irrespective of the choice of y2 can be any arbitrary function, and that arbitrary function will obviously resort to the definition of the differential equation. I'm saying that that has to satisfy the differential equation. If I'm saying that this entire row, entire column has to be 0, it implies that x naught has to be repeated 0. And if at all x naught is a repeated 0 of any of one of the solution, like it can be the repeated 0 here as well. I've just taken an example. So if x naught is a repeated 0 y1, then y1 and y2 are linearly dependent. That is clear. If y1 and y2 are linearly independent, y1 and y2 cannot have repeated 0. Now understand what I want to say, that y1 and y2 are linearly dependent. Given that x naught is a repeated 0, y1 and y2 are linearly dependent for all y2. All y2 means for all choices of y2. Okay, for all choices of y2. So it may so happen that if y2 is sine x, y1 can be written as k sine x. But it says that for all y2 means y2, if it is e ki power x, then I cannot write that e ki power x and k sine x are linearly dependent. Isn't it? So it says that for all choices of y2, y1 must be linearly dependent on it. So there is no such function except for 0 which satisfies this. So if y2 is 0, then y1 will always be linearly dependent on it for any choice of y2. So y2 cannot be all these choices. So for example, I say that if y2 is any non-zero function, which can be sine x, exponential, e ki power x, x square, anything. Now it says that y1 and y2 are linearly dependent on each other for all choices of y2. It cannot be the case. So y2 cannot be any non-zero function. It has to be zero function. And if y2 is 0, it implies y1 is 0. It implies that if x naught is a repeated 0 for any of these functions, that is y1 and y2, then trivial 0 is the only solution to the homogeneous linear differential equation. I know this is difficult, but I hope I'm able to explain. Okay. Has anybody got any problem in this? So this is the theory that I usually teach to mathematics people at undergrad level. So I hope, because you are in postgrad physics, so I hope that this is something that you can absorb. Even if the last statement you cannot absorb, you just remember that if at all there are repeated zeros to the solution for the differential equation, homogeneous linear differential equation, then the solution has to be trivially 0. There is no other way out. Is that clear or is that not clear?
सर लास्ट वाला पोर्शन फिर से बता दो.
Okay. So देखो, what we were doing, we were discussing Wronskian determinant. और अब ये कह रहे हैं हम लोग कि what is one of the other possibilities by which Wronskian can be made 0. So two possibilities we've already checked. There may be another possibilities also. This is a way of explaining things so that your properties you can absorb. So you can say that what if this entire thing becomes 0? So like this way also it can become 0. But what if this entire row becomes 0? What if this entire row becomes 0? And what if this entire column becomes 0? So if this entire column becomes 0, the first thing that comes to mind is that y1 is 0 and y1 dash x naught is also 0. And which I've explained from the theory of roots or zeros, that x naught is then called as the repeated 0. So if x naught is a repeated 0, then y1 and y2 are linearly dependent. Why they are dependent? Because if this is 0, then entire thing would be 0. And at one point, if you know that Wronskian is 0, then Wronskian would be 0 for entire x. The second thing that comes to mind is if you were in mathematics and if you have taken course in discrete mathematics, or if you know something called as mathematical logic, what does it suggest? If P implies Q, then not Q implies not P. These जो सारी चीजें मैं लिख रहा हूँ उस हिसाब से लिख रहा हूँ. That if P implies Q, मतलब अगर y1 and y, if x naught is a repeated 0 of y1, then y1 and y2 are linearly dependent. So not Q means if y1 and y2 are linearly independent, then y1 and y2 cannot have repeated 0. Okay. So that is why I keep saying that people who say that mathematics is science, yes, it is science, but it is more of arts. So it is more of writing things up. It is more of explaining things by your own logic. Like your own means mathematically governed, articulate, and it has to be perfect. Okay, so physics, you can go with okay. But mathematics, you have to be very accurate when it comes to logic. Okay. So if y1 and y2 are linearly independent, then y1 and y2 cannot have repeated zeros. Now, what I want to say is that if this is zero, were you concerned about y2? No. Y2 can be any possible function, right? So अगर ये zero हो रहा है, you are not concerned about this. You're saying that for any choice of y2, my y1 and y2 are linearly dependent. If this becomes zero, if this becomes zero, the column becomes zero. Why would you be concerned about y2? So for any choice of y2, your y1 and y2 are linearly dependent, provided your x naught is a repeated zero. Provided that your x naught is a repeated zero, then y2 or y1 and y2 are linearly dependent on each other for any choice of y2. Now, if y2 was any non-zero function, तो non-zero का मतलब क्या? Sin x भी हो सकता था, exponential x, x square, anything. Like I'm just giving you a few examples. It says that y1 and y2 are linearly dependent. So, for example, if I choose x sin x, so sin x लिखते I'll write y1 would be k sin x. But it says y2 can be anything. Now, y2 if e की power x हुआ, तो k sin x and e की power x are not linearly dependent. So for all choices of y2, y1 has to be linearly dependent. That leaves me no other except function than x y2 x2 be zero. Because if y2 is any non-zero function, then there are several choices. Like there are infinitely many choices for these continuous functions. So if I use these functions, I have to say that for all these functions, y1 must be linearly dependent, which cannot be the case. So y2 has to be trivially zero. If y2 is zero, that implies y1 is zero, implies that yx is the only trivial solution to this particular problem. That is, if x naught is a repeated zero of if x naught happens to be the repeated zero of the solution y1 and y2, then y1 and y2 have to be trivially zero. There is no other way out. कोई और solution हो ही नहीं सकता इस differential equation. ठीक है? I can assert that every non-trivial solution of second order linear differential equation has a simple zero. Because if it has a repeated zero, then it cannot be non-trivial, it has to be trivial. So overall, these are all mathematical theories. As a physics person, you need to remember at least till Wronskian determinant, at least the non-zero and zero aspect of it. That is, non-zero Wronskian determinant would give you a linearly independent solution, and Wronskian determinant equal to zero would give you linearly dependent solution. And what is Abel's formula? Like up till this, if you know, then you are done. Is that clear or is that not clear?
Clear, sir.
Everybody has got the point. सारे बालक कहाँ चले गए? So let us do a last question, and tomorrow we are going to start with the second order homogeneous linear differential equations. So this question was asked in GATE mathematics. So for mathematics students, this is very important. And why do I teach all these difficult things? So that if you go and join some college, some university, if you want to teach some undergrad, you are not at a lack of any such content. You know at least these content. Okay. So I want you people to get an access to every sort of content. For example, if you're to teach a BSc mathematics student also, you can teach. So this is what is additionally you need uh, uh, in order to teach them. Okay. Okay. So this particular question was asked in GATE mathematics. So question says d2y upon dx2 minus 2x dy by dx plus sine e की power 2x square y equal to 0 for all x belongs to 0, 1 such that y1 0 is equal to 0, y2 0 is equals to 1, y1 dash 0 equals to 1, and y2 dash 0 equal to 0, then Wronskian of y1 and y2 at x equal to 1. Just find me this, and this will be it for today. So how to do these questions? So written that d2y upon dx2 minus 2x. And you know that Wronskian at 0 would be equals to what? Wronskian at 0 would be equal to 0, 1, 1, 0. Isn't it? So y1 is 0, y2 is 1 at x equal to 0. So Wronskian at 0 would be equals to, I think, minus 1. And if Wronskian at 0 is equal to minus 1, then Wronskian at 1, I can write it as Wronskian at 0, e की power minus integration from 0 to 1. And what it will be minus 2x divided by 1 dx. So you can write that Wronskian at 1 would be minus 1, e की power, this will become 2, x square by 2, 2 so 2 cancel, we'll have 1. So I can write minus 1 upon a. Is that clear? Sorry, minus 1 upon का option ही नहीं है. अच्छा, sorry. E की power 1 is minus e. Is that clear? Or is that not clear?
Yeah.
Is that clear?
Yes.
Okay, so let us do a difficult question. Again, it was asked in NET examination for mathematics students. June attempt. So what was asked to them was very simple question was there, and most of them left it. I don't know why, but yes, indeed they did. So it says that let P be a continuous function. Let P be a continuous function on R, and W be the Wronskian. The W be the Wronskian of linearly independent solutions y1 and y2 of the differential equation d2y upon dx2 plus 1 plus x square dy by dx plus px y equal to 0 for all x belongs to R. It was given that Wronskian at 1 was A, Wronskian at 2 was B, and Wronskian at 3 was C. Then it was asked that A is less than 0 and B is greater than 0. Option number B, it was given in the exam, was A less than B less than C, or A greater than B greater than C. Option number C, it was asked A upon modulus of A is equals to B upon modulus of B is equal to C upon modulus of C. And option number D, it was asked A, B having like this. So it is a difficult question for you people. I'll somehow do it. So you just see the question. Meanwhile, you just see the question. If you can take the snap, you take the snap so that I will be able to do the question. So given that P be a continuous function, given that P be a continuous function on R, and let W be the Wronskian of linearly independent solutions y1 and y2. And this is the differential equation. And given that Wronskian at 1, Wronskian at 2, and Wronskian at 3 is equal to C, then, so you know that these are non-zero values. If A, B, C are non-zero values, then Wronskian has to be entirely non-zero. Also, you know this from the statement given here that y1 and y2 are linearly independent solution. The Wronskian for y1 and y2 has to be non-zero. It has to be non-zero. Is that clear? So Wronskian x has to be non-zero. Okay. Now, if I know that my Wronskian is non-zero, and secondly, I know that my Wronskian is some constant Wronskian W naught, I'll write e की power minus integration a1 divided by a naught, and instead of a1 I can write 1 plus x square, okay, dx. Okay, this is how I'll write. And if I integrate this stuff up, so I know that in any case this will be modified to Wronskian dash, but overall let me write some constant, and this will be like Wronskian x minus x cubed by 3. Is that clear? So Wronskian can be written in general as a function of x in this form, that is Wronskian at some known point, or in general some constant, e की power minus x cubed by 3. Is that clear? Okay, because
Yes,
there was question that has been asked on the monotonicity of ABC, that whether ABCs are in this fashion or follow this kind of order. What kind of order do you see that ABC would follow? This was asked in the examination. Okay, so I'll take the derivative of it. So if I take the derivative of it, what I'll get? Minus Wronskian naught e की power minus x into x cube by 3, and then I will get 1 plus x square. So e की power, this derivative will give me e की power minus x cube by 3, and the derivative of this will give you 1 plus x square. I know that I don't know about Wronskian naught, but I know certainly that this is positive, exponential is positive. Now, if my Wronskian is negative, then negative will become positive. And so if I'll write that if my Wronskian is negative, it implies what? It implies that Wronskian dash is positive. It implies that Wronskian is an increasing function. I don't know about any of these points. I don't know whether these ABCs are positive or negative, but in general, if my known point, value at known point is positive, then Wronskian would be if this value at W naught is negative, then the Wronskian would be an increasing function, isn't it? If Wronskian is an increasing function, given that 3 is greater than 2 is greater than 1, Wronskian at 3 would be greater than Wronskian at 2 would be greater than Wronskian at 1. You know from the definition of increasing function, if x1 is greater than x2, and if f is an increasing function, then fx1 should also be greater than fx2. So by that way, I can write that W3C is greater than B is greater than A. Or if Wronskian naught is less than 0 की बजाय greater than 0, it implies Wronskian in general is a decreasing function. If it is a decreasing function, given that 3 is greater than 2 is greater than 1, obviously, then Wronskian 3 would be less than Wronskian at 2 would be less than Wronskian at 1, which implies what? It implies that A would be greater than B would be greater than C. So option number B is correct. These two options get rejected. ऐसा हो ही नहीं सकता कि किसी एक पॉइंट पे Wronskian नेगेटिव आ जाए, दूसरा पॉइंट पॉजिटिव आ जाए, बिकॉज इफ एक पॉइंट पे भी इट इज नेगेटिव, if एक पॉइंट पे भी Wronskian is negative, then Wronskian is negative throughout, and if एक पॉइंट पे भी at a single point also, if it is positive, then Wronskian is positive throughout. Now what about this option? I know that what does it imply? It implies writing sine of A, isn't it? अगर आप A को mod A से divide कर रहे हो, what are you doing? You are dividing a number by its magnitude. So basically you are talking of sine. So if you remember from your childhood classes, x by mod x or mod x by x is sometimes referred to as sine function, signum function. So what does it return? It returns you 1 or minus. So it will return you 1 if x is positive, and it will return you minus 1 if x is negative. So I've already told you that if Wronskian x is non-zero, then there may be only two possibilities. Either it will be positive, either it can be negative. It cannot be the case that Wronskian is positive for some values and negative for some other values. No, it cannot be the case. You can see here as well. Exponential is always positive. If you know that it is positive, Wronskian naught is positive, then Wronskian x general is always positive. If you know that Wronskian naught is is negative, then Wronskian x will be negative throughout. So if it is positive, then A would be positive, that is A by mod A if you write, B by mod B if you write, or C by mod C if you write, all these will be equal to 1. And if it is negative, then A by mod A if you write, B by mod B if you write, and C by mod C if you write, it will be equal to minus 1. So option number C is also correct. So both of these options are correct, B and C. Is that clear or not? No doubt this is very difficult for you. Like ये पत्थर मारने वाली बात है तुम्हारे सर पे. But in short, if you achieve this level, then you're going to achieve anything. Okay. So by this, I'm summing up the class. I hope you've got it. And if you've not got it, kindly let me know. Like these are very basic properties to Wronskian function. So if you remember them, it's good and fine. If you don't remember it, again, I'm reiterating, for a physics person, if you know the Abel's formula, and if you know that linearly independent and dependent solution, and the Wronskian for it, that is, a Wronskian would be 0 for linearly dependent solution, a Wronskian would be non-zero for linearly independent solutions. And if you know that how to find the Wronskian for any unknown point, given a known point, then I think you will be able to do everything. Isn't it? इतना घना शांति को पसर गई यार. Rajit and Saloni are only here. Okay. Are you getting my point or not getting?
यस सर।
सर
ओके जी,
लास्ट वाला जो मोड ऑफ बी वाला है वो समझ नहीं आया। बी और
ओके
कोड
समझ
मोड
गए, ओके ओके। देखो मेरी बात सुनने की कोशिश करो। इफ सी I taught you that Wronskian can either be zero or non-zero. If it is non-zero, it will be either positive or negative depending upon what is W naught. W naught means if you know Wronskian at some point. So exponential is always positive, forget about it. Okay, this is always positive. This is always positive. So forget about it. Okay. Now, I can't get a pen. Sorry. So you know that this is always positive. Now, if this is positive, at some point, एक भी point पे तुम्हें पता लग गया Wronskian is positive, then Wronskian x would be positive for all x. Okay, and if at one point you know that Wronskian is negative, then Wronskian x would be negative throughout. Okay, दो चीज समझ में आई। अब समझो कि कोई एक पॉइंट पे आपको पता चल गया कि Wronskian पॉजिटिव है, दैट इंप्लाइज your Wronskian would be positive throughout. If it is positive, then A would be positive, B would also be positive, and C would be positive. After all, these A, B, C's are nothing but the values of the Wronskian at some 1, 2, 3. So if I'm saying it is positive, that is throughout positive, then A would be positive, B would be positive, C would be positive. If A is positive, divide anything by its magnitude, it will be 1. Divide anything by its magnitude, it will be 1. Divide anything by its magnitude, it will be 1. Now, if at all you know that Wronskian is negative at some point, then Wronskian would be throughout negative. And if Wronskian is throughout negative, then A would be negative, B would be negative, and C would be negative. And if these are negative values, divide negative value by its magnitude, it will be -1. इसी वैल्यू को उसके मैग्नीट्यूड से डिवाइड करोगे तो तुम्हें उसका साइन मिलेगा, या तो वो 1 होगा या -1 होगा। अगर -1 है इंप्लाइज इट इज नेगेटिव। सोचो ना, 3 का -3 मान लो, ए -3 को 3 से डिवाइड कर दो तो -1 नहीं आएगा। बी मान लेते -5 है, तो -5 डिवाइड बाय 5 -1 नहीं आएगा। सो इन एनी केस ए बाय मॉड ए, बी बाय मॉड बी, सी बाय मॉड बी वुड बी इक्वल। इज दैट क्लियर नाउ? ओके, चलो हम कल मिलते हैं। टुमारो विल डू मोर ऑफ फिजिक्स, मोर ऑन फिजिक्स साइड, more of these theories on physics side. So for you people, those who are in MSc, kindly do Dirac delta function. I have already recorded those lectures. Place them on the like YouTube playlist. You can go and visit them. There are hardly like 6 lectures right now or 7 lectures. Don't go till Dirac delta potential and quantum mechanics, but Dirac delta function. And also do Green's function. Around 6 lectures are have already been taught. So at least for one-dimensional cases, we'll be able to do the problems which have been asked in the examination. Okay?
Okay.
Okay. Okay, so we'll meet tomorrow. Okay.